Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Today we are going to look at a technique of integration that is going to entail the concept of rational functions. And we have said from our study of numbers that basically the concept of rational functions involve functions which can be expressed, or rational numbers involve numbers which can be expressed in terms of a over b, where b is of course not going to be equivalent to that. So therefore, we're going to look at functions which are going to be of that specific form, and therefore try to find out how we can be able to calculate the various integrals. Now, I've given one of the functions on the board, which is 3x plus 1 over this specific denominator that consists of a range of values which are of course in brackets. So in this case, we're going to have some specific steps that we are going to consider insofar as these partial fractions are concerned. And we're going to, of course, see that this is one of the parts of those partial fractions which basically appear in three categories. And in our specific case, we're going to consider this one as, of course, a linear, a case whereby we're going to have the denominator that has got only linear factors. And these factors are going to be in the form of ax plus b. So in this specific case, we're going to consider this specific aspect of the denominator having these linear factors, as we can see appearing in our example on the board. So we're going to solve this using this specific strategy that I'm going to give on the board, whereby we're going to have this particular expression equivalent. I'm going to equate this one with a over the first portion of this one, which is going to be represented as x plus 2. And of course, this is going to be the sum of b over x plus 1, and then c over x minus 3. So if you create this specific equation, that therefore it's going to assist us to solve and find the values of this a unknowns, a, b, and c given in that specific order. So if you try to create this specific, or do a rearrangement of this specific expression, we're going to have 3x plus 1 being equivalent to a into these specific portions of this specific part of the denominator, which is going to be given as x plus 1, and then into x minus 3. And then we're going to have this second bit for b into this denominator and this one. So we're going to have x plus 2 into x minus 3. And then we're going to have plus c, which is going to be equivalent to the product, of course, equivalent to c into x plus 2, and then into x plus 1 given as such. So this is just a rearrangement of this specific expression that I've given. So first we have this, of course, the partial fraction that has been given a denominator that is only having linear factors given as such. So we're going to equate this one with this specific case whereby we're going to have unknowns for a equivalent. So these are three portions for this first, second, and third one for a, b, and c. So for a, we are going to have it reconciled with the first section of the denominator, b with the second, and c with the third. And therefore, we're going to have an expression for this particular equation with all of this given as such. And if we try to look at this specific case, then therefore we are going to consider a case whereby the value for x is equivalent to 3. So we are going to consider the case for this specific denominators whereby the value of x is equivalent to 3. And we are going to have this one, all of this specific equation given as so therefore the value of x is equal to 3 implies that if we do a substitution for 3 in this specific case, we're going to see that for the section of this first one, the value for a is going to disappear, since x minus 3 minus 3 is equivalent to 0, and the product of this is going to be 0. And for the second case, it's as well going to disappear. This is the substitution for 3 is going to be equivalent to 0, and the value for p is going to disappear. And then we're going to have the value for c. So in this case, for the right section of the equation, the left section of the equation, we're going to do a substitution for 3, and this is going to be equivalent to 10. 10 is equals, so we're going to have only the value for c, which is going to be 0 for A plus 0 for B plus. So a substitution for 3, this one is going to be 5 times 4, which is going to be, of course, equivalent to 20. So this is going to be 20C given as such. So implying in this specific case that therefore the value for C is going to be a half. And if you try to consider for the second case, of course, we can choose any of the two. The value for this specific equation when x is equivalent to, of course, 1, can just consider that, or when x is equivalent to this specific value for negative 1, we're going to consider negative 1, so that we can be able to eliminate for this second case. So we're going to have the expression given as, so this is 3 negative 1 plus this is specific case. So this is 3 negative 1 is going to give us negative 3 plus 1 is going to be negative 2. So implying this left side of the equation is going to give us negative 2, which is going to be equivalent to if we try to do a substitution for negative 1 in the first case, this is going to create a 0 for this part for A, and then we're going to have a 0 as well for this part for C due to this part of the expression that we have seen. So therefore we're going to remain the value of B, whereby A is equivalent to 0, and then B for negative 1, this is going to be negative 2, and then this is going to be positive this is going to be negative 2 and then negative. So this is going to be, we do a substitution for minus 1, this is going to be, of course, 1, and this is going to be, of course, what we call 2. So therefore, this is going to be 4b, given as b into 1 into minus 4, given as such, plus 0. So the value for p in this case is going to be equivalent as well to a half. You can just do a substitution and confirm whether that value is correct as I've given it on the board. So for the first one, we're going to consider a case whereby x is equivalent to negative 2, implying that this specific section for the first one, we're going to have negative 5 as the left value for the left side of the equation is equals. Now if we consider for negative 2, then therefore our expression for this is going to be represented for the value of p is going to be 0 and c is going to be 0. So that's what going to give us the value for a, whereby we're going to have the value for a being given as a into, so for negative 2, then this is going to be equivalent to negative 1 into, the second one is going to be equivalent to negative 5, which basically implies that the value for a is going to be negative 1. So when we have obtained the conditions for this, for the value of a, b, and c for these specific partial parts of the whole fraction, we're going to do a substitution for a, b, and c in this specific case, and then therefore this is going to give us a equivalent to negative 1, and then we're going to have a b which is going to be equivalent to half. So therefore this is going to be 1, and then for the denominator is going to be into 2. So for us to cater for that value of half given as such. So for c as well, we're going to have it represented as c is equivalent to half, so it's 1 over, this is going to be 2. So this is a procedure that we're going to use in finding the unknown sections of these partial fractions that we have derived from this specific part of the rational function for us. So from this specific point, we're going to do the normal derivative procedure that we have been doing for other functions in our various videos. So I'm going to do away with this so that we can be able to use this specific space. So from there, then therefore, we're going to have the integral over this specific function represented as this, and then dx. I'm doing this one for the sake of space. So this one is supposed to be, this should not be as a direct step as I've indicated, but of course I'm just doing this one because of space. So rather I can just do away this so that we cannot be confused along the way. So I'm going to have the integral of 3 plus 1, all over x plus 2 into x plus 1 into x minus 3 dx, given us the negative the integral of 1 over x plus 2, and then plus a half the integral of 1 over x plus 1 plus, so this is dx plus, so this is space, perhaps I can just leave it as such. So we're going to have this one as negative the integral of 1 over x plus 2 dx plus a half the integral of 1 over x plus 1 dx, and then plus a half the integral over 1 over x minus 3 dx, given as such. So this is going to translate into this one if we produce the integral part of that one. And we're going to, from our basic formula that we have been using for the integral of this specific logarithmic function, then therefore we're going to have the natural log, negative the natural log of x plus 2, and then plus a half the natural log of x plus 1, and then we are going to have plus a half the natural log of x minus 3, and then plus c, given as such. So this is how we are going to obtain the integral of rational functions given this specific case. And this is going to be the procedure. And then we can give us feedback on the comment section whether this is you have found a variant way or rather different answer from this. Kindly confirm the answer that we have given on the board. In any case, if we have come across, or rather we have just have a different, have it a different way along the way, so that we can be able to confirm and find out that this is the correct answer. So catch us in our other videos where we're going to look at various examples for these integrals of rational functions, and these are going to complement on other videos that we have already discussed on the same. So that is it for now, guys. Bye, God bless you. Catch us in our next video.